So ladies and gentlemen, once again, we have another example on using mid-ordinate rule. So use the mid-ordinate rule to estimate the integral 1 to 3 of 2 out of root of t dt using 5 ordinates, correct to 3 decimal places. So if they say 5 ordinates, they are talking about 4 sub-intervals. In other words, the number of sub-intervals are always going to be less by 1 on the ordinates. So you get the ordinates, less it by 1, then you get the number of sub-intervals. Now this is 5 minus 1. That's what we are trying to say. So how is the sub-intervals going to help us? They are the ones we are going to use in our numerical methods to estimate this approximate integral or to approximate the integral of this. So what does that mean? We are going to look for h, which is the width of each sub-interval. So what is h? H is b minus a out of 2. B is the upper limit, a is the lower limit. So this is going, this is divided by n. This is divided by n. So this is going to be 3 minus 1 divided by n, which is 4. This is 2 out of 4, and this is 0.5. Meaning, we are going to be moving from 1 to 3, but at a space, we are going to be getting points between 1 and 3 at a space of 0.5. So meaning if we start from 1, we will be going to 1.5, okay? From there, we will be going to 2.0, 2.5, and therefore to 3.0. So what are the midpoints? The midpoints that we have to use are between the x0 and x1. So x0 is this, x1 is this. So divide, get these, sum of them, then get their midpoint by dividing by 2. So from here to there, in the middle we have 1.25. In the middle of this, 1.5 and 2, we shall have 1.75. In the middle of this, we shall have 2.25. In the middle of this, we will have 2.75. So those are the x ordinates that we are going to use to estimate the value of the function f of x is equal to y is equal to 2 out of t. So since here we are using t, so we shall replace x with t. So the values of t are going to be 1.25, 1.75, 2.25, and 2.75. So what is the value of f of t at t equal to 1.25? So we are looking for f of t, okay, which is equal to 2 out of t to power a half. So in other words, what are those values going to be? So put in let 2 divided by square root of 1.25. What do you get here? We have approximately 1.7889. And if I substitute 1.75 into this, this is 2 out of root of 1.75. So I get, on my calculator, I get 1.5119. If I put in 2.25, I get 1.3333. I'm using 4 decimal places, so let me maintain the same. So 2.25, okay? So this is going to be 2 out of root of 2.75. And what I'm getting is 1.2060. So what is my formula that I'm going to use? Our formula is always integral from a to b, f of x with respect to x is approximately equal to h into y naught plus y1 plus dash dash up to plus yn minus 1. Okay, If you say you are using y1, then it will be up to yn. Okay? Yes. So let's move and put in these values. So if we substitute in, we'll find that integral from 1 to 3 of 2 out of root of t with respect to t is going to be approximately equal to h, which is 0.5 into 1.7889 plus 1.5119 plus 1.3333 plus 1.2060. So what is the answer here? I'm getting an answer approximately equal to 2.920 to 3 decimal places. If you want to go ahead and integrate this, substitute in these limits and find the value. So it is always going to be approximately. It is not exactly this, but it is approximately equal to this. Therefore, the mid-ordinate rule has been used to approximate the integral of 2 out of root of t with respect to t, and from the interval x is equal to t is equal to 1 up to t is equal to 3.